This episode of Liquid Assets is sponsored by Hasa, the leader in water treatment solutions. Hasa delivers eco-friendly, reliable, and cost-effective water care and has been keeping communities safe, one drop at a time. They've been at it for more than 60 years, and you can learn more about Hasa by visiting hasa.com. That's HASA, hasa.com.
Hi everyone, my name is Jose and I am the CEO and founder of Segura. Segura enables anyone anywhere to test for key priority contaminants in water like lead and arsenic in under 5 minutes. It's fast, it's affordable, it's easy to use, and it's all managed through a digital interface.
Welcome to Liquid Assets, a podcast where we talk about water and its intersection through the world and the lens of business, management, and technology. I'm your host, Ravi Karani, and today we have an awesome guest for you, Jose Roberto from Segura. Jose, how are you doing today?
Great, living the dream, cannot complain.
You're calling in from where in the world?
I am in Oxford today. I'm usually on the road, but have spent the past three years here in Oxford in the UK.
Awesome. Really, really cool. I want to jump into a topic we were talking about right before I hit record. And you grew up in Guatemala. You were talking about how you believe in market solutions for kind of solving the world's problems. And you had a really interesting story about how you actually used to treat your own water, take it, pick it up. Can you just walk the audience through what you were telling me and your worldview on that?
Yeah. For context, I grew up in Guatemala in the city, and I've been lived in India as well for a couple of years. I wouldn't call myself the most, neoliberal pro-market person out there, but I think a lot of the problem and big of reason why, like foreign air and like the water and development kind of industry, so to call it, has not achieved its goals after, maybe trillions of dollars spent by now and, decades of work, is, by being so top down, and not being very, market driven or not really putting financial sustainability at the heart of it. And I think that's something that's right now there's so much chaos going on with like USAID cuts and well, even before last year, I think there was already some big changes going on in that industry. Like you see UN agencies having to go and fundraise from philanthropy, for example. And I think that lack of focus on financial sustainability, more than just market, but really just make sure you get good cash flow and that you're able to cover your operations and have a little more. That's never been like the way things are done, and I think philanthropy should have been or should be seen as similar to startup, some pre-seed funding to get you to the point that you can be financially sustainable and even grow. But the way it's been done, it's continue to get a project, get funded, but not, the goal is never actually been to reach financial sustainability. I think there are some efforts that are changing that, the work that some people at Oxford do that's related to that, in strengthening the institutions on the ground themselves to become viable businesses, but overall the industry as a whole doesn't fully operate that way.
Let's kind of dig into that really quick. If you were to change the system, right? And whether that's removing philanthropy from the conversation or just potentially changing the coordinate system of how businesses, government, people view that. I'm not trying to seed anything, but like, how would you structure it? Like, what would it look like in Jose's world?
Yeah, I think there's definitely a role for philanthropy, especially in places where, there's no, sufficient local government funding or where you just given the geographical landscape and the the urban density just doesn't make sense for centralized supplies to exist. But yeah, my perspective is the external funding should only be as an aid to get to be a self-sustained operation, which needs to consider alternative ways of generating revenue. I think maybe in the past that was harder, but now you get blue credits, was, some people even do some, like crypto. There's a lot of other things out there. Maybe I'm saying all this from a very privileged position, but overall, I think today there's a lot more options for generating financially sustainable operations than there was, before like access to internet was so democratized.
For sure. I think that's actually a really interesting topic and one that we haven't covered on the podcast before. You jumped a little bit into like blue credits and crypto. Do you have a few quick bullet points of other revenue generating streams that water can use?
I think the blue credit economy, or just same as carbon credit, are still, well, carbon credits are of course much further along, and they have also not fulfilled their mission for the most part. I think blue credits have seen some success, like for voluntary carbon markets for water, for example. It seems like it's been a stretch, the kind of narrative that you have to, you replace carbon because now you use these filters as opposed to burning wood, and that gives you some credits, and that's how you fund operations. It seems a little crazy that sometimes that's the kind of like jumps you have to get the funding, but that's one. I know there are people like working at the intersection of water infrastructure and blockchain, and like biodiversity credits as well. So I think there's new things coming up in like financing. Maybe not my topic of full expertise.
Sure. Makes sense. Really cool. Let's jump over to Segura. We started off with your story in Guatemala. You have a really interesting story. I won't spoil too much for the audience because I'd love to hear it from you. But walk us through, let's jump into Segura first. Let's talk about kind of what you guys do. And then I'd love to, after that, rewind the tape and figure out the intent or kind of the origination story of how it started.
Yeah. So briefly, Segura is an Oxford-based water quality monitoring startup. We leverage the same technology that's used in glucometers, so where you pinch your finger and you get a number, that applied for water monitoring applications. We have found some space in like drinking water utilities, particularly in use cases where sending samples to the lab is either too expensive or just doesn't make sense. Things, for example, lead testing for like lead and copper rule compliance in the US. We just finished a 4-month proof of concept with the New York Department of Environmental Protection looking specifically at that. And we have found a few other kind of similar use cases in which it's much preferred to do it on site. Some application in process optimization, for example, that we're going to be exploring, looking at arsenic removal, but also an iron and copper testing for water treatment. The iron and copper in high concentrations can affect filtration for pools, as you know better than I do. But sometimes people send it to the lab because there's not good tools to measure that on site. But with this, we're able to get a recommendation for treatment or replacement of a filter way quicker. And mining is another thing. Some food and beverage. A lot of places where sending where traditional lab infrastructure is, if it exists, hard to reach. We've seen some good interest. I think that's an avenue we're really trying to get to. Like north of Mexico, for example, with a lot of food and beverage companies that export to the US. We've been talking to some South African like regional hubs that produce beverages that then get exported to the rest of the region. Of course, in Central America as well. There's a lot of places in which sending samples to the lab is the least optimal option.
So I want to deconstruct that for the audience a little bit. We have folks that actually listen to the podcast that are not in the world of water. And so there's a few things I want to backtrack on. You had mentioned lead testing for the NYDP. We see stories on lead a lot. if you were explaining this to me as a 5-year-old, like why? Let's just go back to the basics, right? Like why is lead bad? And where is lead found? You know, people are like, oh, every single pipe has lead inside there, and they see this Flint, Michigan problem. Yeah, like walk us through just the basics of what is lead and why is lead bad, and like how prevalent is it?
Yeah, so lead is a known neurotoxin. It's particularly bad for children and women. It gets stored in bones, actually. So when you're this pregnant woman and there's a baby being formed, the lead that gets stored in the bones actually gets released and forms the skeleton of the baby. But then that actually affects brain development, and it's been linked to a lot of behavioral issues, of disease, and it has had a lot of historical impacts. Actually, some people claim that the fall of the Roman Empire is due to like lead contamination on the like vessels that used to be used for keeping the wine, that led to a lot of behavioral issues and health issues. I don't know exactly how that has been tested, that theory, but I think there's something there. In terms of the prevalence, I think that's actually the problem. We don't fully know. We know it's there for historical reasons. In the US, it was banned in the 80s, in the UK in the 70s. So it used to be a construction material that's really cheap to use because it's very malleable. So it's very cheaper than copper or other materials to make plumbing material. But in other places where maybe we hadn't thought about it so much is, where it's pumps, like hand pumps. They recently, in the past 5-10 years, have also been found to have lead exceedances. There's some research in a number of African countries finding 80% of the pumps having exceedance levels of lead. So I think it's a more widespread problem than we realize. There's a lot of medical evidence that show that it's really bad, and we're just gathering pieces to realize that it's actually probably more prevalent than we even think.
And what is NYDP or just any sort of regulatory body currently doing? You had mentioned that sending a sample to the lab. Let's deconstruct that really quick. Like what's happening? Like why do people send? You obviously make an in situ testing device, and so what's currently happening today?
Yeah, so New York, unlike many cities around the US and around the world, they have done their part and replaced their own infrastructure throughout the years to remove the lead. But there still remains on the private side, it's usually called. So, there will be a big pipe from the utility, but then the connection to the house, that one's actually made out of lead, or some walls, some parts in the walls, those are made out of lead. That's usually where the issues are. And, there will be some reason why a customer will request a test. Maybe some discoloration, or it was in the news, so then they got worried. And by law in the US, you're as a utility, if someone requests, you're obligated to send and do a sample. But currently, the only method they have is they have to send a sampler. The sampler follows a standard protocol and then ship them all the way back to the lab. And then in the lab, they use this $500,000 like machine that's the size of a fridge. To produce a test. It takes them anywhere between 2 to 6 weeks to produce a single data point. Cost them around $120, upwards of $200 when you account for all the logistics, all the labor, all the consumables. But the idea is that with this, they're actually able to respond to this customer complaints and customer concerns a lot quicker, and identify, now because you only are able to, do a few samples that you send to the lab. With this, you can test 3, 4, 5 taps, if you will, very quickly on the same kind of moment. So that actually gives you an idea of where the lead is coming from, which then allows you then to find a solution. But yeah, it's this is really a tool for the water manager, so to speak. I think maybe that's one clarification that I often do, that this doesn't solve the problem right away. Like, the lead's still going to be there, but for the people that are dealing with the water and managing, having a tool like this gives them a lot more control and reduces their costs on testing very significantly.
So let's draw a comparison really quick. You had mentioned it takes about 1.5 to 2 weeks, and there's this $500,000 machine that somebody would have to put in the capital expenditure to buy that. What's the cost per test and time? And not even considering the fact that you have to actually take a sample and mail it or send it somehow to this laboratory. What does that look like between Segura and what's currently happening?
Yeah, actually I have a slide here. Let me see what we said. Okay, we got some numbers from them. If you include all of the steps, it includes 7 to 8 people. 8 to 9 people, taking up to 6 weeks. Cost per sample being from $225 to almost $560. With Segura, it involves 1 to 2 people, results in less than 5 minutes, costing, again, with labor and everything included, $25 to $60. So can save upwards of even 90% non-direct costs, but also I think there's a lot of savings as well in the fines that you could potentially get as a utility if you do find lead. I'm not sure I'm remembering this correctly, but I think a fine can be like $25,000 a day for some of these known issues. So if it takes you 6 weeks to realize that you're in a really bad position, but if you know right away that you're above 50 ppb or 15, depending where you are, then you're actually able to get to a solution much quicker and avoid those fines.
Let's jump to your other markets. You had mentioned arsenic, iron, copper, mining, food and beverage. I think the drinking water piece, I understand decently well off of your explanation. How does this translate over to these other markets, and what's happening there?
Yeah, let's start with mining. I think that one's one that was kind of randomly inbound. Somebody heard, that we can measure like multiple metals on site very accurately, and then they asked, "Hey, can you measure in like, can you measure high copper, the parts per million, and in this type of samples?" And the answer is we probably can. We're still kind of in the process of validating some data there, but the problem they're facing there is, they have to do a lot of monitoring for environmental compliance reasons. They're mandated to make sure that the water on their sites is not leaching onto, like water bodies that people use for recreation or for drinking water. So they spend a lot of money on testing, and a lot of these sites are, of course, very remote. So they have spent a lot of money on, getting infrastructure to be able to test. So they would sometimes set up labs in these remote places, which cost them tons of money. They have also this one customer thing specifically. They have spent millions and thousands of hours working on different inline monitors that are kind of the ideal for this application, but that have not been able to fully solve the problem. So this is kind of giving an option to still be able to produce in situ data very quickly with a lot of extra control over the chemistry. I think that's the advantage with this. You can spike your samples, you can run blanks. Now with the inline monitor, it's a little more autonomous, so you don't have as much control. But if you have a trained operator, which these people normally are, then you actually have a lot of insight into, is the process that we're running to treat the water working or not, or is this just, a fluke? And you can always test before and after the process to actually see if there's a difference. And that's more on the process optimization kind of angle.
Really cool. And how does this play in the food and beverage side?
Similar situation. For an example, I won't say the name of the company, but they have 130 abstraction points in their kind of Southern Africa regional hub, and they produced beer. And some of those sites receive municipal supplies, which they trust, but some of the other ones are groundwater or surface water. And setting up 130 labs is, it's just not possible. Like, that would cost way too much money. So they do have some system to send samples from all those sites to a centralized lab. But it's once a week, and if they do have an issue of a process that's not running well, or they did find some exceedances, it will always be too late. Like, that's the problem with lab testing, that it's even if it was 2 days or even like a few hours, like it's already too late if you're producing the rest and you have to be shipping every day. But that's the idea, that they're actually able to test 10 times a day. That's kind of what we've been discussing on site very quickly, as opposed to having to send samples to the lab.
Really cool. I had an episode with Ruben Vollmer, who is the CEO of Spout. They make a atmospheric generator for generating water, and he had a really interesting episode on heavy metals through the California fires. And so I think there, because as the pipes were melting or burning, there was a lot of particulates and pollutants that were going to the water stream. And he had actually brought up on the podcast that water testing obviously is so delayed that they just have a kind of do not drink or boil water advisory, because it's just going to take like 2 weeks or 2.5 weeks to really get the data. But then the time has just passed, right? The thing you should have acted on is 2 weeks ago.
Yeah, no, lab testing is, it is the gold standard. Like, I'm not saying this is going to replace it, but for a lot, I don't know if most, but a lot of use cases, it makes more sense to have something quicker. And then for confirmation or for compliance purpose, you send, one compliance sample to the lab that is not as urgent. So I actually do think all these things go together: lab testing, field tool, like inline monitors. I think having all of them, that's really like the powerful way of managing risk. But today we kind of only have labs for the most part.
Really interesting, Jose. I want to rewind the tape then really quick, and let's go back to the origin story. You can trace this back as far as you want. I'd love to see from entrepreneurs what in their upbringing, what their parents did, how they grew up, that started to take DNA into kind of what they're working on today. And so you can rewind as far as you want. You can kind of jump, but I want to give you the agency to be able to like tell us that story.
Yeah. Because when I was 10, I don't know, I grew up in my grandma's house, and that's it's a very old house, and in Guatemala City, you don't, at least where she lives, you don't get 24/7, 7 days a week water. You get 5 days a week, from like 4 a.m. to like 6 p.m. So it's a time of the day that you have to fill up your water containers, because otherwise you won't have water, and you also have to keep some for showering. And that's that was pretty normal for me. I then eventually figured out that's actually not how it is everywhere in the world. Like, some people actually have water on demand all the time. But we had to when these containers, we will add bleach to the containers, a couple drops. I remember very vividly my grandma doing that. That's supposed to be an emergency kind of measurement, but for us, that's what to do. I think it was shocking to have that realization a little bit, that I think it's just that we just don't have water even in the capital. Well, now my parents moved to an apartment, and it's a newer building, and it has its own pump and all that. So now we do have water, but even it's still like in my grandma's house, like it's still now not 24/7, 365. So that's just the reality. And fast forward to college, I studied chemistry. I studied chemistry in the US, and have it's an ACS certified degree, and I was very focused on analytical chemistry and measuring things. I was very interested. And that I joined a professor working on a sensor for things like PFAS, on lead, and all of that. And that's kind of how I first found water as a subject. But of course, from the technical side, but then there was the sociology side, the business side, the management. So I found it extremely interesting, because you have to align all these things to craft a real solution. So I already had the water bug bit me after my second year of my undergrad, I suppose. But when I graduated, I actually joined a startup. in LA, it was a biomedical startup making glucose monitors, especially CGMs, like the ones that you put in your arm. So I was, very, very familiar with the commercial development of these decentralized technologies, which vendors, which strategies, which IP strategies to use. Not from like an academic perspective, how do you make sure that what you're doing can be scaled up to the place that the unit economics make sense? And I think that has had a great impact on the way, Segura has gone. Like today, we're less than 2 years old. But if someone tomorrow wanted to order 10,000 of these strips and, 1,000 readers, we could do that. Like we have the capability, and that's not trivial to achieve. And that's something that, we had to be nailed down from the beginning, because, in the lab, you can do whatever. But then can you actually produce that and make it, like have the unit economics make sense? That's a challenge in itself that takes years and millions to figure out. We were able to, kind of work from the beginning with some contract manufacturers that were, able to plug and play some pre-existing solutions for us to bring this to market a lot quicker. And yeah, I think there have been some really great startups in the past that have created really great solutions that have actually solved the pain points, but then never been able to scale to that point in which, the unit economics make sense and the volumes make sense. Because of course, the price per test, are relatively low. You're talking, less than lab testing. So, $10-$20 per test at most. So if you want to have a business that, it's going to be financially sustainable, if not investable, then you need volume, right? Like you need to do hundreds of thousands of tests. So that's part of the reason why we're so much focused on distribution at the moment. Like the tech is there, but that's that even if it wasn't there, it can be figured out. But distribution is really the key. Part of the reason why in the fall went through the Techstars powered by Ecolab program, trying to figure out what would a relationship of that nature take, and would like to get to the point that you build this the pipelines of distribution, because direct sales are with some large clients like New York, LA, that's fine. They're like big contracts. But the bulk of the demand is in the like small, medium clients that are hard to reach, and that just type of funnel work is very expensive and very hard to do, like market entry. Coming back to I guess where I went to grad school to study water management. Well, that's actually the reason why I'm here in Oxford. Study water management, and we work very closely with a professor here that's also in the area of water quality, and she works mostly in like the development space. And she also said that there's a really good application for this tool in those places where labs are hard to get, and even the one that you do get are also not the most reliable always. So you have something that you have a lot of control over the chemistry. That's not a black box. And that's fast, and that's at the right price. You can actually have a lot of impact for a lot of people, for a lot of people that are managing the water, and then by extension, by a lot of people that are drinking the water. After my degree, I briefly worked in engineering consulting, did a lot of, project bidding and a lot of the optioneering work myself. So did also get some insight on how does a big business operate, and if you want to actually get to those contracts, what do you have to do? So that's another huge thing that's been for trying to play the game, which takes time, and it's bureaucratic. And in the UK, there's like 5-year admin cycles called apps. So it's right now is the beginning of the new one. So if you want it to be used today, we were probably already 2 years too late. But I think we understand that piece that it's not there's the regulation, there's engineering consultant, there's utilities, and you can have to play the game.
Such an inspiring story. So if I see the road correctly, you went from storing in Guatemala, growing up in your grandmother's home, where you had to put chlorine drops and only got water 5 days a week. Studying chemistry, joined the glucose startup in LA, and then you had this stint of kind of Oxford, bridging in the gap. I totally see the glucose monitor startup plus how Segura measures the water chemistry. And then going through engineering consulting. So you actually understand the sales cycle, the process of how to actually get to the same customers that Segura is getting in today.
Yeah, I think maybe not just the sales cycle, but actually the language. And I think that makes a huge difference. Like if you say, lead pipes, that's not the same as saying that's 6 out of 10. Lead service line, which is more the language that's used in the industry, that gives you more credibility. If you say lead service line for inventory, or galvanized lines requiring replacement, when you speak the same language, even though the two technologies can do the same, you probably go with the one that's actually specifically connecting the dots.
Sure. Yeah. When you look at parts in your path that got you to where you are, I want to rewind the tape again really quick. And where in there do you see like a big juncture that you took the turn that now got you to Segura, but there was like a fork in the road where you could have done something else? Like what was that time that comes to mind right now?
There's two answers. The first one is that I had some visa issues, and I couldn't, continue my comfortable engineering job. I had to, I just had to stop doing that because of my visa and regulation. That's just how the world is these days. So then, that was a good opportunity for me to actually, jump in, test the waters, I suppose, on this idea that I had. And there was actually an investor at the time, kind of, it just lined up very well, that was a friend of a friend, hey, we're launching this new kind of project for climate solutions out of the Oxford ecosystem. If you had an idea, you should apply. And then we did, and then we got it. So it was good timing there. But the other fork in the road earlier is that I actually went to boarding school in India, which is super random. But I went to this international school. I got a scholarship, and it was a very mission-driven organization. There were people from all over the world, called United World College. Some people may know about it. And I think that put me on this kind of change the world path, and some the mission, but also kind of the responsibility, because I've gotten a lot of responsibility, a lot of scholarships. For example, I got a scholarship for my undergrad, I got a scholarship for high school, I got a scholarship for Oxford, and I do have some sense of responsibility on that. Even being an immigrant in the US, the capacity in which I was there is very different from most Guatemalans. So I do have some sense of I suppose the responsibility, just a mission that I'm supposed to be. Not supposed to be. I am really driven to be working on solutions that can help a lot of people.
If you look at the Segura now standing where you are, with everywhere that you've come from, what does the next 10 years look like, right? Now I want you to fast forward the tape. What does that look like?
I think there are a couple of milestones that we really want to hit. One of them, become compliance methods. So certification with the WHO, the EPA, and that's those I think that we already started working on. Because that will enable us to actually become a completely trusted solution. Right now, it's there's chemistry, but again, not aligned to the regulation yet. So I think that medium term, I don't like saying long term, because that kind of always means never. But short, medium term, become getting all the certifications so that if a small utility in Guatemala wants to adopt a tool, which actually some are, then they will be able to this is a WHO certified technology, so you can actually use it for this application, and become the go-to for this application. Really changed instead of people sending samples to the lab, being knowing that these technologies exist and are more commonplace. I think that's really, and being the go-to, of course, of the field monitoring. Of course, there's a lot of incumbents, but think we have a lot of, like, we have technical advantages. We're the only one that's able to measure several metals at once. I think most of the things are will only like lead at once, and then copper, silver, and test. So those are 2 tests. We do it in like 1 test, like many metals in one go, which is what people need to do anyway. And we're also pushing a lot for like digitization, like everything is done through an app and API connected. And if you're already using some, asset management software, if you're a big utility or a small one, I think there's been a lot of, push on the industry to come, do everything, not pen and paper or Excel, but actually some smart dashboards. We are really interested in, being very naturally integrated into that kind of workflow. And at the same time, being able to collect a lot of data. I think there's a lot of possibilities to integrate eventually with like, remote sensing, forecasting, things like that, to create like really powerful data sets. So, yeah.
I want to touch on something before we close out the episode that you mentioned in the beginning. And you have a role, and I've worked in the engineering consulting world. We wanted to kind of quickly talk about the role of engineering consultants in this entire process. Talk kind of me and the audience through what your thoughts were there, what the kind of problems are, and how you see fixing it.
Yeah, well, I think the first thing to note is that, utilities, or, us mostly public entities, are not engineering firms. Their job is literally to spend the money, like, not to design, not to, build filters or to like that. That's where the engineering consulting firms, and I think that's a good thing. Like, the utility, the government's kind of just administer the resources, but then the people with the degrees and with the knowledge, they're the ones that are kind of offering the services to different utilities. Like, it wouldn't make sense for such specialized people to be stationed in one utility. I think it's good that that's the way it is. But then obviously that adds another layer to the procurement, or just to the way solutions actually enter the market, because it's the engineering consulting firm that then proposes something to the utility, to the client. So if you go directly to the utility, which is I think what most like startups would attempt, you're probably not in the right place. But then the drivers for engineering firms are also different. They actually have, I think, somewhat of an incentive, not so much to innovate, because they, their trust and making sure they deliver what they need to deliver is more important than the risk of trying something new that they personally may like it and they trust it and may know it's good, but then without sufficient proof of concept, it's too risky for them to propose something new, and then you risk the contracts or the reputation at the cost of that. But then that creates a bit of a cycle that there's no proof of concept because you're not pushing it, but then you're not pushing it because there's no proof of concept. So there's definitely some role there for some. I would say they're very different. Like, I've spoken with one that like, we just use standard methods because that's what the clients want. But some other ones are like, oh, that's cool. We're open to trying new things and see, send us some data, send us some equipment, and see how we like it. Some are really like, they do innovation, but like it's all in-house. So I think they're different. And even some of them have like venture firms. I know Mud McDonald have a digital like ventures fund that they look specifically at digital companies that are in the like asset management or infrastructure space. So they're different, but I think it's just a matter of their incentives and the risk. For them, there's too much risk and not that much incentive at the moment. Yeah,
totally makes sense. I ask everybody this question before we sign off, Jose, and it's, do you have a book, a movie, or a TV show that has had like a profound impact on the way that you see the world?
I don't know if you would know this, well, maybe this book, but it's Season of Migration to the North, which is one of the most famous books from like the Arabic-speaking world that have been translated into English from a Sudanese author. And I think it's mostly from my experience as as an immigrant that's been kind of, in Guatemala, but now I'm in the UK, and kind of across those two sides of the river. I think the experiences there of the main character and the kind of antagonist have been very, have been very instrumental in how I see the world. I think that's definitely one that comes to mind. And I would recommend. It's a really fun book anyway. Like, it's very beautifully written, and I think everyone should read it. It's nice.
Awesome. We'll find the link and throw it in the show notes. Jose, thanks a ton for joining us today.